Hello students, once again we are in chemistry lesson with your teacher Abbas Mdungi Mohammed. I think you are ready to join our today's lesson, and today's lesson is the second session of atomic theory. Since our first theory was Dalton atomic theory, and we have seen postulate that proposed by John Dalton. As always, we are in chemistry. And today we are going to see the modification of Dalton theory that makes to create new or modern Dalton atomic theory. So our objectives today, we have only one very important objective, which is at the end of the lesson, students should be able to explain the modern concept of Dalton atomic theory. So that is our objective today. By starting our lesson today, I would like to remind you that we have learned about Dalton atomic theory. So do you remember those 5 postulates that proposed by Dalton? Do you remember them? Okay. So let me remind you, these are Dalton atomic theory. I'm going to show you there, using this piece of manila sheet, the first postulate, although it is on other version, but it sounds same as in meaning. Matter is comprised of small particles called atoms. That is the first one. The second one is atoms can neither be created nor destroyed, causing chemical reactions. Postulate number 3 is an element consists of only one type of atom. An element consists of only one type of atom. Postulate 4 says atom of an element differ from atom of another element in mass and also chemical properties. Postulate number 5 says atoms of different elements may combine in a simple ratio to form compound. Atoms of a different element may combine in simple ratio to form compound. Now, after Dalton theory, there are different scientists which we can call them modern scientists, that working out on Dalton theory to find the truth of Dalton. At the end, during to development of scientific tools, for example, microscope, so they found their new discoveries. So they discovered more about atoms. And those scientists are example of scientists is Ernest Rutherford. We have a lot of scientists, but 4 of them is, another one is J.J. Thomson, also working hard on this theory to find the answer where Mr. Dalton left or did not explain. We have James Chadwick, and also Michael Faraday also explained something on atomic structure and is taken as his contribution. So, why these scientists challenge Dalton theory? They found that there are some limitations on that first Dalton theory, and these limitations include Dalton theory failed to explain how atoms combine. The other limitation is Dalton did not explain how and why atoms combine to form compound. But also, in this theory, it does not explain the force that hold the atom together in combination. But also, the theory did not explain the distinction between atom and molecule. And that's why those scientists come and from their finding and development, they try to modify Dalton theory. So there are some modifications made by them from each of the following postulates. The modifications are as follows. Let's remove these pictures first, put it over there. I've got some modifications, but I just want to read them. Then you are going to tell me that modification may be related to which postulate. I will take randomly. This modification says atom of same element may have different mass. And this is shown by isotopes. Atoms of same element may have different masses. What do you think? This is the modification. So we just want to match those Dalton theory of atom and that kind of modification, where this modification correct. The first one says matter is comprises of a small particle called atom. The second one says atom can neither be created nor destroyed. The third one says an element consists of only one type of atom. This one, fourth atom of one element differ from atom of another element in mass. This one says atom of different elements may combine in a simple ratio. I repeat, this says atom of some element may combine, may have different masses. We are talking about mass in this postulate, so it means that there is repetition in mass in this postulate. Atom of same element may have different masses, isotope. Atom of one element differ from another in mass. So it means that this postulate match. So the modification of this postulate, this may match over here. Atom of one element differ from atom of another element in mass, but atom of same element may have different in mass. So do you think is it clear to put it over here? So we shall see. So let's put the heading there. Now we are in modification of Dalton theory. Atom of same element may have different masses. Atom of element differ. Atom of one element differ from atom of another element in mass. But in case of same element, maybe their atom differ in masses, which is isotopes. For example, isotope of carbon may have 12, another carbon may have 13 mass, and another carbon may have 14 mass. So that is the meaning, just an example. Okay, now I take another one randomly and show you. It says atom contains subatomic particles, which are, into bracket, protons, electrons, and neutrons. Atom contains subatomic particles, which are protons, electrons, and neutrons. So now, let's look on those postulates, Dalton atomic theory. The first one says matter is comprises of small particle called atom. Here is atom contains subatomic particle. So since it's a small particles, or another version says teeny indivisible particle. So it means that it's going to be these modifications going to correct Dalton by saying small particle. Because when you say small particle, whereby inside that small particle there are some subatomic particles. So by saying small or teeny invisible particle, you mean that you make it smaller as not small at all, because no longer indivisible, as the modification says. So another modification of that Dalton atomic theory, we have this one. It's a atom can be created by nuclear fusion, also be destroyed by nuclear fission. So we have nuclear fusion, which atom can be created, and we have nuclear fission, whereby electron can be, whereby atom can be destroyed. So directly we have atom can neither be created nor destroyed. But this one opposes that statement. So we can put over here because it matches. Atom, So atom can neither be created nor destroyed. Here we have atom can be created by nuclear fusion, also can be destroyed by nuclear fission. So it means that this is becoming the modification of the second postulate. So let's go on this postulate. We have another postulate. It says atom of different element can have some similarities. Atoms of different element can have some similarities. For example, sodium, atom sodium, the number of neutrons in atom sodium, we are talking about subatomic particles, is 12. Then also, the number of neutrons for magnesium is also 12. So they both have 12 neutrons. So it means that we are talking about, look at this. One element consists of one type of atom. This one, atom of one element differ from atom of other in mass. So atom of one element differ from one atom of other in mass, also in some properties. So still, there are two postulates or two modifications come to challenge that postulate of Dalton atomic theory. So here we are talking about atom from different element to have same property. Here we have one atom or atom of one element to have different property, for example, different mass. So it means that both of them try to modify, try to challenge the Dalton theory of atomic. So I think the last postulate, we have last postulate, but one among the postulates do not have any comment or any challenges. Let's have, I hold that the last one. The last one says, atom may combine in any ratio to form complex compound. Here we have an example of starch molecule where number of carbon is 6, number of hydrogen is 10, and number of oxygen is 5. So there is multiple of n. So where n is in whole number. So this modification says atoms, I repeat, atom may combine in any ratio to form complex compound. Since there are two, Dalton theory is our postulate, number 3 and number 5. Let's read the first one to make sure which one is matched. An element consists of only one type of atom. Here we are talking about atom may combine, so we are talking about combination. But this one, the last one says atom of different elements may combine. So we are talking about the combination. It means that we have something in common. So we make sure that this match to the fifth postulate of Dalton atomic theory. The statement says atom may combine in any ratio. This one is said atom of different elements may combine in a simple ratio. Here, in any ratio to form complex compound. As you remember that in this postulate, we give example of water that it contains 2 hydrogen atoms with 1 oxygen atom. But here, we have seen that in any ratio because some of the atom may be contain a higher number of atoms and some contain in lower number of atoms in the same compound. And that's why we call it an example of complex compound. Now, what do you think if I rearrange? Are you going to arrange them according to the postulates, or are you be able to match them? Let me try. Okay, now, I've rearranged them. So we want to have that kind of activity to make sure that we match the postulates of Dalton atomic theory and the one which modified. So I will use that marker pen, temporary marker pen, to show just an arrow to show that this will be corresponding to that modification. So I start with the first one. Matter comprises of small particles called atom. Matter comprises of small particles called atom. Now, we have atom may combine in any ratio to form complex compound. So, is this resemble that one? Is it? Yes, no. No. Atom can neither be created nor destroyed. Let's finish with that first one. What about the second? Atom can be created in nuclear fission, also be destroyed in nuclear fission. This one is nuclear fusion, this one is nuclear fission. It's about creation. This one about comprising of small particle. So I think this is also not correct. Atom of different element can be same, can have same similarities. So here we have about small particle. Here we have about small similarities. Atom of same element may have different masses. Also, this one also is not a correct modification. Atom contains subatomic particles, protons, electrons, and neutrons. So I think this one could be correct one. So I just want to show, to indicate that the first postulate for Dalton atomic theory resemble with this modification, which listed is the fifth one. Now, let's come with the second one. Atom can neither be created nor destroyed in a chemical reaction. So, according to the first postulate, first modification, we say that atom may combine in any ratio to form complex compound. This one is about creation and the way it could be destroyed. The second one, atom can be created by nuclear fusion, also be destroyed by nuclear fission. So it means that it's about creation, also there's something in common also about creation. So it means that this one directly resembles to this one. This could be the Dalton atomic theory, and that one could be its modification. So they are matched. Okay, the last one is, the third one is an element consists of only one type of atom. So there's that atom may combine in any ratio to form complex compound. It's not yet been used, and this atom of different element may combine. Atom of different elements can have same similarities. Atom of some element, atom of same element may have different masses or isotope. So I think an element consists of only one type of atom. There's no modification that directly target to this postulate of Dalton. In continuation, we have atom of one element differ from atom of another element in mass. So atom may combine, so it is not the target. Also, atom of different element can have same similarity. So this one is resemble that explain or try to describe and challenge this post-Dalton atomic theory. And atom of same element may have different masses. Also, it's talking about masses as Dalton postulate, on first postulate. So both these postulates have been challenged by two modifications. One is talking about particularly same element, individual element, but atom from same element to have different masses. And also this talk about different element to have same property, for example, number of neutron in case of sodium, which has number of neutron in case of sodium, which has 23 mass with 11 electron, and magnesium, which has 24 in mass and 12 atomic number. So by subtracting 24 by 12, we have 12, and subtracting 23 by 11, we have also 12. And this is the total number of neutron in each case. So it seems that this property become the same or resemble from sodium to magnesium. In development, we always have some challenges. As Dalton, we found that Dalton have some limitation that being corrected by modern scientists. So when we develop, we have to make mistakes, errors, and we are calling them challenge. We are not sometimes not call them problems, because sometimes problems make people fail. We just call them challenge, because what we have to do with challenge, we don't have to run away from challenge. We have to accept them, and we have to turn the challenge to opportunities. So what I want to do, what I want to tell you, my students, that you always have to change or turning challenges to opportunity. That is the end of my today's lesson. I hope we are going to meet on other session of chemistry lesson. Bye-bye.